You invest in biometric dive tech, heart rate monitors, breathing sensors, temperature tracking, because you want better dive safety. But here's something most divers learn the hard way. Those sensors are only as reliable as your pre-dive setup. Skip the calibration, and you're just carrying fancy paperweights underwater. My name's Marcus Okafor, and I'm going to walk you through the complete biometric dive safety checklist that actually keeps your data accurate and your decisions sound.
You're listening to the Scuba Gear Lab podcast. Quick heads up before we dive in. Everything you're about to hear is researched, fact-checked, and written by real people who actually test this gear, but the voice delivering it is AI-generated. Just want to keep that transparent. Now, if you're a regular here, thanks for coming back. Honestly, it's great knowing this content's landing with people who care about the details. And if this is your first time tuning in, welcome aboard. We drop new episodes every Monday, Wednesday, and Friday, so you've got a steady stream of gear breakdowns, safety protocols, and real-world testing headed your way. Today, we're talking about biometric dive sensors and the pre-dive checklist that keeps your data accurate instead of worthless. Let's jump in.
I've watched divers skip calibration steps because they're eager to get in the water, only to surface with completely bogus heart rate data or breathing metrics that made no physiological sense. Whether you're using a dedicated biometric dive computer or standalone sensors integrated with your existing dive computer, this checklist ensures your biometric data is accurate, reliable, and actually useful for monitoring your dive stress and gas consumption patterns. Now, let's talk about the physical inspection you need to do before you even think about powering up your biometric system. I learned this the hard way on a drift dive in Cozumel when a partially flooded heart rate chest strap gave me readings that jumped between 45 and 210 beats per minute, neither of which reflected my actual physiological state. First, check your heart rate chest strap condition. Examine the entire strap for cracks, worn elastic, or corroded contact points where salt buildup commonly occurs after multiple dives. If you're using optical sensors, wrist-worn units, or dive computers with optical heart rate monitoring, verify those sensor windows are clean. Any debris, sunscreen residue, or micro-scratches can scatter the LED light and corrupt your readings entirely. Check the link below to see the current price for the Garmin Descent G1 if you're looking at wrist-worn options. Inspect sensor contact surfaces for corrosion. Marine-grade stainless steel contacts should show no pitting or green oxidation. If you see corrosion, clean with white vinegar and a soft brush, or replace the sensor assembly. For chest strap systems, test your electrode gel or conductive material. Those conductive surfaces must be slightly damp or gel-treated to maintain electrical contact. Dry contacts mean no signal transmission. Check your battery compartment O-ring integrity. Even a tiny grain of sand under the battery cap O-ring can allow a pressure leak that floods the sensor at depth. Remove the cap, inspect the O-ring for cuts or deformation, and lightly lubricate with silicone grease. Verify your mounting hardware is secure. Whether it's a chest strap buckle, a wrist computer strap, or tank-mounted sensor bracket, loose hardware means sensor movement that introduces motion artifacts into your data. Confirm wireless connectivity antennas are intact. The small plastic antenna covers on ANT Plus and Bluetooth sensors are fragile and can crack during gear transport. A damaged antenna means intermittent signal dropout underwater. And if your system uses wired sensor integration, test waterproof seals on those wired connections. Inspect every connector, cable bland, and sealed port for proper engagement. Water ingress at depth will kill the electronics and potentially damage your primary dive computer. Moving on to sensor calibration and baseline establishment. This is where most divers cut corners, and it's exactly where biometric systems fail most often. Factory calibrations drift over time, and your personal physiological baseline changes with fitness level, hydration, and recent dive activity. I calibrate every sensor before every dive day, not just when I feel like it. Establish your resting heart rate baseline. Sit quietly for 5 minutes before diving and record your resting heart rate. This becomes your comparison point for understanding exertion levels and stress responses during the actual dive. Perform breathing rate sensor 0-point calibration. Many tank-mounted breathing sensors require a pre-dive atmospheric pressure reference. Follow the manufacturer's specific procedure, usually holding a button for 3 to 5 seconds until you see a confirmation indicator, to set the 0 point. Sync your time and date settings. Biometric data is worthless if the timestamps don't match your dive computer logs. Verify that all devices share the same time reference so you can correlate physiological data with depth, time, and decompression information later. Configure personal biometric thresholds. Set your maximum and minimum heart rate alarms based on your actual fitness level, not generic defaults. A 55-year-old diver and a 25-year-old diver have vastly different safe operating ranges. Verify altitude and barometric pressure correction. If you're diving at altitude or traveled by air recently, many sensors need manual altitude input to correctly calculate breathing rates and gas consumption. Check your device manual for the specific procedure. Test sensor to computer pairing and signal strength. Power on all devices and verify strong signal connection before gearing up. Weak pairing at the surface usually means complete signal loss at depth when electromagnetic propagation through water degrades further. Perform a skin contact test. For optical sensors, the device should register a stable heart rate within 10 to 15 seconds of proper contact. If it takes longer or jumps erratically, adjust the fit, clean the sensor, or troubleshoot the contact surface. Document battery voltage levels. Most biometric sensors display remaining battery capacity. Anything below 30% means you're risking a mid-dive failure, and replacing batteries at that threshold prevents surprises during your safety stop. Next up, integration with your dive computer and data systems. Standalone biometric sensors are interesting gadgets, but they become safety tools only when properly integrated with your dive planning and decompression algorithms. I've seen too many divers collect beautiful heart rate graphs that had zero connection to their actual dive profile because they never completed this integration step. Verify wireless protocol compatibility. Confirm your sensors use the same wireless standard, ANT+, Bluetooth LE, or proprietary protocols as your receiving device. Mixed protocols simply won't communicate, regardless of brand promises. Enable biometric data logging in your dive computer. Many dive computers with heart rate monitoring capabilities ship with biometric logging disabled by default to save battery. Dig into your settings menu and enable all relevant data channels. Configure real-time display preferences. Decide which biometric metrics you want visible during the dive versus post-dive analysis only. Cluttered displays underwater are counterproductive, so I typically display only heart rate in real time and review breathing rate after surfacing. Set up physiological alarm thresholds. Configure your dive computer to alert you when heart rate exceeds your safe maximum or when breathing rate indicates stress or excessive gas consumption patterns. Test data transmission underwater. Before leaving the dock, perform a shallow 10-foot test dive to confirm sensors transmit through water at your specific setup configuration. Electromagnetic signal propagation varies dramatically with sensor placement, body composition, and mounting geometry. Verify data synchronization with logbook software. If you're using digital dive logging platforms, confirm that biometric data transfers correctly from your dive computer. Many systems require specific export formats or third-party sync applications. Configure decompression model biometric integration. Advanced algorithms like those in the Shearwater NERD2 can adjust conservatism factors based on real-time workload and stress indicators from biometric data. Enable these features if your computer supports them. Now let's talk about environmental and personal factors. Biometric sensors don't operate in isolation. They're affected by everything from water temperature to your previous night's sleep quality. This section covers the contextual factors that influence sensor accuracy and data interpretation, based on patterns I've observed across hundreds of logged biometric dives. Assess your current hydration status. Dehydration increases heart rate and alters breathing patterns independently of dive stress. Drink water deliberately before diving and understand that biometric baselines shift with hydration levels. Check skin temperature and perfusion. Cold extremities mean reduced blood flow to optical sensors on wrists or fingers, resulting in weak or absent signals. If your hands are cold before splashing, expect optical sensors to fail until blood flow increases with activity. Verify proper sensor placement for your body type. Chest strap position varies with body composition. Place the sensors just below the pectoral muscles, where rib definition is palpable, not up near the sternum, where strap movement causes artifacts. Consider recent physical activity. If you just hauled tanks down a rocky beach or geared up in significant heat, your pre-dive baseline is artificially elevated and won't reflect your actual resting state for calibration purposes. Account for medication effects. Beta blockers, stimulants, antihistamines, and decongestants all alter heart rate and breathing patterns. If you're on medication, establish your personal baseline while on that medication rather than using historic reference data. Review recent dive history and residual nitrogen. Successive dive days accumulate fatigue that elevates baseline heart rate and breathing rate, even when you feel subjectively rested. Compare current baselines to your day one calibration to track accumulated fatigue. Check for skin irritation or allergic reactions. Chest strap contact dermatitis or wrist sensor pressure points can cause fidgeting and poor sensor contact that degrades data quality throughout the dive. Evaluate environmental temperature extremes. Both cold water diving and tropical surface intervals can cause heat-related tachycardia before you even descend. Here's your final check before you go. Run through this compressed checklist in the final 5 minutes before splashing. This is your last chance to catch calibration errors or hardware problems before they become underwater complications. All sensor battery indicators show adequate charge, above 30%. Wireless pairing confirmed with strong signal between all devices. Sensors show stable readings during a 30-second stationary test. Dive computer displays biometric data on main screen. Personal alarm thresholds configured and enabled. Time and date synchronized across all devices. Sensor contact surfaces clean and properly positioned. Baseline resting heart rate documented for this dive. Backup dive plan doesn't depend on biometric data functioning. Post-dive data export method confirmed and ready. I keep this final checklist on a small laminated card attached to my BCD inflator hose so I can review it even after gearing up fully. There's nothing more frustrating than discovering a calibration problem at 60 feet when it's too late to fix it. Let me hit some frequently asked questions. How often do you need to recalibrate biometric dive sensors? Calibrate biometric sensors before each dive day and after any battery replacement, firmware update, or extended storage period exceeding 2 weeks. Sensors that sit unused for weeks can drift from factory specifications due to temperature cycling and component aging. For daily diving on a dive trip, perform a full calibration each morning and verify baseline readings between dives, but you don't need complete recalibration between afternoon dives on the same day unless you notice erratic readings. Can you use medical-grade heart rate monitors instead of dive-specific sensors? Standard medical or fitness heart rate monitors are not pressure-rated or waterproof to scuba depths and will fail or flood beyond shallow snorkeling depths, typically catastrophically at pressures exceeding 2 to 3 atmospheres. Dive-specific biometric sensors use sealed housings with pressure compensation, marine-grade materials, and algorithms calibrated for underwater electromagnetic propagation. The Polar H10 chest strap is waterproof to 30 meters for surface swimming, but is not rated for compressed gas diving, while proper dive sensors are tested and certified to 100 to 200 meter depths depending on the model. Check the link below for current pricing on the Polar H10 if you're curious. What should you do if your biometric sensor gives inconsistent readings during a dive? If you notice erratic or physiologically impossible readings during a dive, such as heart rates above 200 beats per minute while neutrally buoyant, or breathing rates that don't correlate with your perceived exertion, stop relying on that data immediately and revert to your standard dive plan without biometric input. After surfacing, check for obvious hardware problems like loose sensor straps, corroded contacts, or low battery indicators. Then perform a complete recalibration sequence before attempting another dive with that sensor. Inconsistent data is worse than no data because it can drive poor decisions about exertion levels and gas consumption. So here are my final thoughts. Biometric dive technology represents a genuine advancement in how we understand our physiological responses underwater, but only when the sensors are properly calibrated, correctly positioned, and thoughtfully integrated into your overall dive planning process. I've spent enough dives troubleshooting failed sensors and analyzing garbage data to know that the pre-dive checklist matters as much as the technology itself. The difference between useful biometric data and electronic noise comes down to discipline in following these calibration and verification procedures before every dive. Take the extra 10 minutes to run through this biometric dive safety checklist properly, and you'll build confidence in the data these sensors provide. Skip the steps, and you're just carrying extra weight underwater with no safety benefit. Your biometric sensors should enhance your dive safety awareness, not replace your fundamental understanding of dive physiology and gas management. Treat them as supplemental information that helps you recognize patterns in your workload, stress responses, and gas consumption, but never make critical safety decisions based solely on sensor readings without cross-referencing your training, experience, and actual dive conditions. That's the approach that's kept my biometric data both accurate and genuinely useful across more than 400 dives with these systems. That wraps up this episode of the Scuba Gear Lab podcast. Thanks for spending your time with me on this one. New episodes come out every Monday, Wednesday, and Friday, so you've always got something fresh to listen to. If you got value out of this, I'd really appreciate it if you could leave a 5-star rating and write a quick review. It genuinely helps other divers find the show when they're searching for solid gear education. And make sure you're subscribed or following so you get notified the second a new episode drops. I'll catch you next time.